Welcome. Thanks for coming. We're happy to have you here today for our Cornell keynote on hardware and AI development. So just a little bit of a quick starter. I want to talk about what Cornell does with hardware, what we're doing here. So I'm from an organization called CREA, the Center for Regional and Economic Advancement, and I work at a downtown business incubator in Ithaca called REV. So REV has some specific unique opportunities in hardware that even though we're domain agnostic, we bring in entrepreneurs of all types. We have a prototyping shop where we can support hardware development with physical products to actually walk through, design, test, iterate, so that hardware entrepreneurs can bring their products from a concept all the way up through production. So a little bit, just briefly, to talk about what we do with those hardware programs. We have two different programs, a prototyping program and a manufacturing program. The prototyping program runs over the summer, and it's to bring basically a napkin sketch all the way up to a prototype that you can give to ideally a customer to do some quick testing with. And then our manufacturing program is a year-long program that takes that first prototype and helps you go from building one to building at scale. So hundreds of thousands up to 1 million even, but looking at what that process is from you made one, but you can't make 100, maybe 1,000, 100,000 that way. So how do you change the process to build at scale? Our prototyping program has 3 different tracks. We have an ag tech track that looks at farming and food types of technologies, a climate tech track, which looks at reducing greenhouse gases. That can be really broadly interpreted. It could be heating, saving on power, could be vehicle related, could be a number of different things, even down to waste. So that's our clean tech track. And then we have a classic track that takes anyone else with a hardware idea. And the main goal here is that you just have to have a physical product. And so we have these 3 tracks to help put you with a like-minded cohort and that you can collaborate with these groups. But those are our programs. The idea here why we wanted to talk about this is because hardware has some specific, unique challenges. We've seen a lot of advancements in hardware and then a lot of advancements in AI at the same time. And we're seeing more integrations between them. So we have a great lineup of guest speakers for you today. I'm super excited to hear from them. They all have different experiences with different types of hardware and at different scales. They're all at different parts in their journey. So I want to take a second to let them introduce themselves and tell us a little bit about their backgrounds. So I want to start with Professor Anna Thornton to tell us a little bit about your experience, your interest in hardware, and what your background is around hardware and technologies.
Well, thank you very much, and nice to meet everybody. So my background is I started as an academic. I was a professor at MIT for about 6 or 7 years, and then decided that I really enjoyed being on the factory floor more than I enjoyed writing papers with differential equations in them. No offense to faculty members who write those, but not my cup of tea. So I ended up spending about 20 years in a combination of large companies and small companies, helping companies do things around product design, quality, hardware, manufacturing, launch, production, supply chain, et cetera. I then came back to academia about 6 years ago as a professor of practice at BU. While there, one of the things that I was asked to do was to really look at how are we educating our future engineers to be able to launch new products as part of our product design and manufacturing program at BU. And so part of that was developing a course called Product Realization, which is really that process that Deanna mentioned in the second phase, which is going from 1 to 1 million, and how do you do that? And to date, that process has been sort of trained almost like an apprenticeship in companies. And what I saw was a lot of young hardware companies really struggling with understanding the incredible complexity involved in getting that idea into launch. And so I wrote a book called Product Realization, which hopefully saves me a lot of long conversations because I just send people to chapters. In fact, I sent Ryan off to the chapter on certifications recently. And I continue to help support young companies in that process, as well as my teaching.
Great. Thanks so much, Anna. I always love hearing about the new projects that you have going on and the great setup you have over at BU. So now let's introduce Micah. If you want to tell us a little bit about your background, where you are with your product, and your journey through hardware development.
Yeah, awesome. Thanks, Deanna. Hey, my name is Micah Green. I'm the founder, president, and CEO of Talos, formerly MadeBot. And my journey actually started at Cornell. So I went to the hotel school and worked as a room attendant as part of my hotel operations class, cleaning the Statler Hotel, for anyone familiar. And that was the aha moment. So naturally, I'd been building robots since I was 5 years old, saw this huge opportunity to bring robotics into the space. And our vision for the company is, if you've ever seen the Jetsons, Rosie the robot, full out humanoid robot. So ended up pursuing that, actually joined the Rev Hardware Accelerator the first year. Ken was one of my first mentors, and that really helped us kind of get things going. So yeah, I've been working on that, and our robots focus on commercial cleaning for hotels, office space, airports, universities, essentially any commercial real estate. We've been ramping things up. It's been really exciting.
Great to hear it. I'm excited to see that you're going to be moving to scale, and hoping you'll talk a little bit more about that over the course of this discussion. And our last guest speaker, also a Cornell alum, also part of one of our prototyping accelerators from this last summer, is Ryan Lee. Ryan, do you want to talk a little bit about your background and where you are with your product right now?
Sure. Yeah. This is Ryan here. I was Cornell Chemical Engineering year 2012. So I'm a plumber of things that flow. That pertains to gas, liquids, data, electricity, right, capital. And that's sort of my career up to this point. I built very large hardware for companies like Shell Oil Company and very large software for Alibaba, helping manufacturers around the world grow through e-commerce technologies. But nothing compares to starting my own business. I took the leap of faith in entrepreneurship at the end of last year, beginning this year, full-time hustle. I'm building an AI-enabled power cube to help users turn off plugged-in home electronics to save energy and reduce their carbon footprint in their homes. Was fortunate enough to go through the Rev Hardware Accelerator program, got the hardware into a really good stage for production, and also currently being accelerated at Techstars for the business growth.
Awesome. Thanks, Ryan. So really excited to hear from all of you today. I'm going to go through some questions for each of you. So I'm going to start with Micah. You mentioned that you've been building robots since you were 5. You came across this opportunity while you were at Cornell in the hotel school. I would love to hear a little bit more about how AI and advancements of technology have given you a specific, unique market opportunity, or how that's been advantageous for you as you started out this journey.
Yeah, for sure. So when I started the company, I was actually wondering why, Roomba and Neato and Dyson hadn't gotten into the space. So some of the consumer robots hadn't gotten into hotels specifically. And really what I found was it was about durability, cleanliness, but most importantly was efficiencies as well. So there was a huge gap in the market. Those products just didn't make sense at all when it came to an industrial use case or commercial use case. So really leaned into that early on and saw this huge opportunity to build out a navigation stack, essentially self-driving software that's optimized for the commercial setting. So for example, our robot takes 6 minutes to clean a room, whereas a Roomba might take up to an hour. So we spent a ton of time, invested a ton of time in the navigation side of things, obstacle avoidance, built out machine learning. And then throughout the course of getting units out there and getting feedback from the customers too, we saw opportunities beyond just the kind of efficiency side of things, but also in terms of the setup. So we created something where our robots don't need any sort of mapping or integration with a new property, which in commercial robotics is kind of unheard of. You typically need to take weeks or even sometimes months to set up a new property. So we built a ton of kind of pipeline and software on the back end to support that. And then another advantage I'd say is at the end of the day, you need the users to love the product and to want to use the product and to consistently use it. So we spent a ton of time on user experience where the robot's actually ready to use right out of the box, which has a lot of kind of AI as part of that. And then we say press play and walk away. You just press a play button. A lot of these users, the room attendants or housekeepers, might not speak English or be able to read. So building something that's really universal, super easy to use. And there's a lot that kind of goes in the back end from that. So all those pillars in terms of kind of the efficiencies, the user experience, the scalability, and getting things set up are super important, at least for our specific use case. And all of that's powered by different software, different AI and machine learning that we built out. So yeah, those are some of the key things we've worked on.
Great, thanks. So now, Ryan, I have a similar question. I love thinking about your product because you're using AI essentially in a way that is a little bit unique because you're working on essentially a power strip, but you've transitioned it into this totally different item in the home. And so I know you just finished up your Kickstarter campaign. I'd love to hear a little bit about how you learned about your market and the community. Are people really responsive to taking a simple object like a power cube and turning that into an AI-enabled device? Are there skeptical people? How did you build that community, and what did that kind of look like for you?
Yeah, I'll just begin to say that, probably people have heard about phantom load or vampire energy, or you've certainly been told, hey, unplug your appliances or devices after use to save energy. That really pertains to that 2 a.m., standby printer that's never really printing anything, or your red dot on your TV, right? And so you may be familiar with these things in your life already, but you just don't know to what extent are these things being inefficient and draining power after they're turned off or in standby. And that's when we start to bring that to light to users by measuring. That's the first thing. We share what the machine sees with what the user sees and let them know, oh, yeah, I'm incurring this inefficiency. And so when we hit the market, there was a general understanding and, oh, wow, that's what it is. Oh, that's where that inefficiency comes from. And that's how much it's basically costing me and costing the planet in terms of carbon footprinting and emissions. And so that is what we've kind of went to market with. But even still, there's a good bit of skepticism of, is this truly plug and save? Can I just plug in my devices as if it's a regular power strip and trust your AI to be turning my things on and off for me? Will it disrupt my lifestyle? And so on and so forth. So there's an element of education. And what I find being helpful is that, drawing things that people are familiar with, already using in their home, like, for instance, the Nest thermostat. It has that learning aspect in your home. It tunes your temperature, right, based on your behavior, usage, and utility grid information. Well, we are that, except just for your home office equipment or your TV entertainment systems. So that kind of helps overcome, a little bit of that skepticism around it. And of course, the best way is to show and not just tell. So we've had samples been set to users, and they are experiencing that in their homes and writing us reviews about our product, which then really helps. So that's what we've learned largely in our Kickstarter campaign and going to market.
Great. I just have a quick follow-up on that, actually. And then I want to get to Anna. But do you find that people are resistant to having their behaviors learned? Do you think people are worried about this? Or is this something that, you mentioned the Nest that we're all used to by now? Yeah.
Following that question of, does this work? Is this AI? Is well, how do you protect my data privacy? What if I need to violate, or what if I need to be in control, right? And so there's that we need to kind of address and answer. So being really transparent as a business, showing, hey, we're taking your information solely to help guide you for the purpose of saving you energy and cutting off power when you don't need it without disrupting your lifestyle. So it's very much a crawl, walk, run type of approach with our users. So it does take time for them to really experience it and feel it.
Great. So Anna, I'd love to hear a little bit of your thoughts around, how this all then fits into the larger landscape of hardware and manufacturing, right? Ryan and Micah both have individual projects. Does AI play into some of these larger scale systems? Do we have new tools that help us do hardware better? What's going on in the larger space?
So, if you look at the larger space, if we sort of divide it into pieces, so sort of that creative front end where you're generating those ideas and you're generating those prototypes and putting that together. Obviously, the AI is incredibly important on the software side of things, but I don't really see, there's all sorts of tools that are promising new and innovative ways of doing that front end. But to a certain extent, it's just human power that has to do that. That's really where that creativity comes from. That's where that generation comes from. And then I would say sort of through that process of once you've got that prototype, once you've got that idea, going through those first few stages, especially as a small company, a lot of that is really not going to have an AI component to it. Most of it can be done in spreadsheets, and almost adding that complexity of AI and machine learning is a layer of complexity that kind of almost gets in the way of, and there's a lot of tools that have been promising to do that, but to be perfectly honest, a lot of it's just the work of managing that process. Now, there are a ton of new tools around PLM, and they're doing better at that. One of the things that I found with a lot of the PLM tools is that they're really designed for large organizations. They're not really well designed for small organizations, that there's almost too much overhead. There's an opportunity for some business person who wants to build PLM systems for small startups. And I would say really where you start getting into that machine learning and the AIs, one is obviously in some of the inspection and quality control once you get into production. Most of that is really going to be in your printed circuit boards, in your inspection, visual inspection for aesthetics. But most of that technology is independent of whether you're a startup or a large company. Really where I see the new technology coming in is once you're at scale. And so obviously a lot of the tools around warranty analysis and customer complaint analysis, or being able to go out and find a ton of data about what is being said about your product on the internet, or in the wider set of social media. There's a ton of new tools around that. Some of the sourcing, there seems to be some new initiatives around sourcing. And then once you're managing your factory, there's a huge amount around IoT, inventory control, SKU management, et cetera, that's occurring at the large factory basis. But I would say for the probable audience of this talk, which is, I'm assuming, is going to be predominantly hardware startups, a lot of it can be just done with Excel and pen and paper. And I wouldn't get too in the weeds, just because at some point you just have to have a bill of materials, and that bill of materials for a new product is probably going to be simple enough that you don't need to have that extra layer on top of it.
Right, that's great. And so maybe just to reword that a little bit. So it sounds like you're saying that when you're looking to do something like an AI or a new smarter system, really that doesn't come into play until you're looking at very large volumes or really large scale. And that if you're starting out as a hardware entrepreneur, maybe not to go too deep into that too early on.
Yeah, I mean, you've got enough problems to focus on. Just figuring out what parts you're going to include in the design, and are they available, and is the supply chain out there. Adding that level of complexity of adding software and everything else on top of it. A lot of it is just phone calls, who do you know, making those connections, getting really good advisors who can point you in the right direction, making sure that you've checked all the boxes. There's no tool that AI is going to tell you what your durability requirements are for your product. You have to live that product. You have to do that storyboard. You have to understand those touch points. You've got to watch your customers using that product. You've got to see how they're going to misuse it. You're going to have to see how that environment is going to be there. Is it on the floor, and is there going to be a kid going at it? Or is somebody going to be vacuuming and hitting it? But there's no software that's going to do that and is going to be able to imagine what that life of the product is going to be like. You can get some of that information through looking at social media once your product's in the market, to look for trends on what people are saying about it. But for that front end, it's just work. It's just what you have to do as a designer. You can't outsource your design intent.
That's great. I think Micah and Ryan would probably agree with a lot of the statements you had in there, that it's just work. You need to get it done. And there's plenty of other challenges to focus on with hardware.
Yeah.
So, Micah, I want to jump back to you. You are working on a really hot topic right now in AI, looking a little bit at autonomous navigation. You mentioned moving towards a fully humanoid robot. I'd love to hear a little bit about how you've managed those challenges and how they've evolved as you've gone down this journey.
Yeah. What challenges? It's been super easy and seamless the whole time. Yeah, I can resonate a lot, and just was nodding my head a lot to what Anna was just mentioning. There's enough things to kind of work through. So, and I'll start, I mean, honestly, just being transparent, it took us over 6 years to get to our final product, even though it's not final. It's never done, in my opinion. There's always stuff we need to work on, but there have been so many challenges. And when you're building a mini self-driving car, there's a lot of edge cases and a lot of different things that you have to think about and work through that you might not, in the office, right? So totally agree with Anna that getting out in the real world is huge. And that's where we found a lot of different things. And you need time to do that too. There's a lot of survival and a lot of, having the capital to keep going to work through these things. So yeah, again, just want to echo Anna in terms of getting out in the real world is just so important. And in terms of the testing side of things, we've done so much testing and you just can't find some of these things out in the office, right? We have mock hotel rooms where we're testing our robots, which is great, but then you add a user, right? And different things there. So one example that we found in terms of a challenge is actually room attendants or housekeepers. They leave their door open into the hallway. We didn't realize that. So the robots would kind of escape and start cleaning the hallways when we didn't want them to. So we added machine learning that now is implemented and working super well to determine which doors go to the hallway, which doors go to other parts of the room that are okay to clean. And same with elevators. Another thing we found is that our robots cleaning the hallways, you might have pilots that are resting during the daytime when the robots are cleaning, and they're vacuums, right? So you can hear them. And although they're quieter than what's out there today, you can still hear that buzzing. So we got some complaints from some of the guests that said, hey, I don't want to just keep hearing this buzzing for, an hour and a half. So we had to change our algorithms to then clean in front of a space for a short period of time, rather than going all the way down and back in a hallway, clean that space, move on to the next section. So those are just like a couple real world examples. But that being said, we also implemented simulation and spent a lot of time and effort actually in building out as realistic of a simulation environment that we can, that, replicates things like gravity and friction and different sorts of furniture and stuff like that. And then built out some machine learning there as well, so we can simulate, thousands and thousands of different sort of environments and situations to be able to get as the best accurate data before we get into the real world. And that's been super helpful in terms of trying to find some of these challenges and bugs before we, start going out into the real world and even before we, put it in users' hands. And around that, we've kind of refocused, I'd say, as an engineering organization and team in terms of quality. So we've hired on a couple of test engineers, both for hardware and software, to build out test procedures and protocols around that. And then that's been super helpful. And again, trying to get some of these, find some of these challenges or bugs or whatnot before we get out there. And the last piece that's been awesome is it's a pretty tight-knit community, I'd say, around robotics, both online and then just with the relationships we have. So we definitely have shared war stories with, different companies that we're friendly with. We've heard lessons learned there, and we're even trying to, build a stronger community around that so we can have this communication flow. So we don't have to recreate the wheel and others in the community don't either.
No, that's great input. Just a quick follow-up, because I loved hearing this little story. You mentioned that you would come across this one instance where cleaning people were leaving the doors open, and then you had to account for that in their models. I'm sure a lot of people have heard about autonomous navigation and thinking about those edge cases. Have you come across any other interesting edge cases in the hotel world? Are you expecting to come across more? How do you kind of handle them one by one as they come in?
Yeah, for sure. So I think there's always going to be these edge cases. And if you look at like self-driving cars, there's a reason we don't all use self-driving cars today, right? And I think there's that last 5% or 10% is really tricky. So what we try and do is focus in on certain environments like hotels and like specific types of brands and specific types of operations where we can try and at least minimize those or mitigate those, edge cases. But yeah, those are some of the user side of things. Even the thing I mentioned earlier of like language. We used to have text and a bunch of kind of elements of our user experience. We had to strip that down to literally just a play button. Because, an edge case of, hey, one of our properties has, they speak 14 languages in one of their teams. So, when you're designing for that, you got to strip away the complexities too. And then you have furniture edge cases. You have, different things that could pop up, like a dog popping into the room or certain furniture or types of like luggage that come in. So we try and, test that, and luckily dog friendly office, which helps, but still, I'd say we're always going to be learning something. And the goal is, how do we focus on the environment, and the use case, and market where those are mitigated as much as we can.
Great. Thanks so much for sharing. So, Ryan, I want to talk a little bit more about the bigger picture environment. So you're looking at, green solutions and improving climate opportunities here. Can you talk a little bit about, what you see as the future of hardware and sustainability? Does AI have a role in the future of green products? What's kind of your view on that?
Yeah, absolutely. I'll just, preface this by saying that, adding AI capability to a hardware actually opens up more doors for you and opportunities for you in terms of the business model. So take a product like mine, right? It's like, it's a power strip. If you boil it down to just the hardware, goes from one outlet to the wall, extended to multiple different types of electronics that you get to plug in. And that's what the traditional power strip is. It's just a commodity of extending power. But then now you have an AI layer into it, right? That learns when you're using things, the power profiles of those devices, and then data you don't typically see as the user, which is the local utility grid. And then it's able to make predictions on what you plug in and what the relative energy efficiency of those types of devices, and then be able to recommend when to turn things on and off, or help you even upgrade the efficiency of your equipment. And so there's a lot of applications and value you can derive from having AI being layered onto a hardware. And that, in a sense, is a transformation for a business model. We can do this for consumers, just for energy saving purposes, but then we can also apply that to businesses as well. And that's what we've learned in our customer discovery. You take a place like a museum, right? And so the museum operator is actually very much aware of phantom load. They turn things off, not just for energy saving purposes, but also for facility safety, right? So think about all the insurance they pay on the fine arts that's collected in the museum, right? And so they're acutely aware that electronics should be turned off when they're not necessarily in need to, prevent fire hazards, right? So you layer these applications on, and you present to a customer like a museum. It's not just an ESG feel-good metric. It's not just energy savings. It's also to lower your, property casualty insurance, and that's a good package of value that you get to deliver to your end customer. And I think that is what's really exciting about integrating AI into hardware.
That's awesome. I did not know that about museums. So thank you for sharing and informing me today. One of the questions that I have then for Anna, to go back to you, we have this like ongoing battle with hardware where it's just going to take longer to build an airplane than it is to launch the next iteration of software. Are we going to catch up? Are we catching up? How do we kind of manage that battle of hardware just takes longer? Where are we going with this?
So there's a number of things. One, hardware's getting it. It is hard, but it is getting a little bit easier. If I look at what it took, and I won't date myself, but when I started in the product development space, the lead time for injection molding was 14 weeks. Now you can get as fast as 6. The lead time for printed circuit boards was months, and you had to really know what you're doing. Nowadays, you can easily go and get prototype boards. 3D printing, easy prototyping, high-speed machining, et cetera, has really decreased that time scale. And I think as a result has increased our ability to do a lot of iterations and take risks. And so as we are looking at the technologies that we're supporting in the hardware process, I do believe that's going to continue. I would say the second biggest risk is around our financing. Educating our venture capitalists, our seed funders, our angel investors, is a big load on a lot of our hardware folks, because there's just this understanding that it's hard tech. I mean, it takes a long time to convince somebody of how long it's going to take and then the potential return. That said, if you kind of look at products as a box, and that box, you've got a bunch of information that's coming in, and then that information is being used in some way, and then it is having an action on the outside world. Okay. If you just look at software, you're taking input from a person, or maybe, but ultimately you're taking that input from some level of hardware. And then that output might just be on a screen. Whereas with a hardware, a physical device, all of a sudden you have mobile ability to take measurements. You have the a physical ability to be in a space. You have the physical ability to modify that space. Hardware gives you just so many more ways of getting data in and then physically changing the space around you. And at some point, apps are great. Investment people love apps because it's quick, it's easy, the load is easy. I won't opine on my belief on some of the software unicorns and where there's going. The New York Times is doing that well enough for me today. All I have to do is open up the front page and they're already sort of talking about some of the risks associated with that. But if you look at sort of what hardware does, I think it will always have a place. Now, I doubt we are going to be creating products that are solely hardware. I think it's really that integration of we're just not building things or little wooden toys that I used to get for Christmas. Objects in and of themselves are easily replicable. It's hard to maintain intellectual property on. It's hard to scale. They very quickly become commoditized, whereas that combination of sensors, measurement, intelligence, data analysis, your AI, and then that ability to uniquely transmit that information either through information screens or through actually, as what Mike is doing, Orion's doing, turning off the power or vacuuming something or cleaning something in a room. That ability to connect the incoming data and then the outcoming action. That's hard to copy. That's much easier to ensure patent. It's your intellectual property. It's much easier to ensure trade secrets. It's much easier to create platforms that are hard to break into and to create a competitive advantage, to be able to compete against. So I really see that marriage between those two is really where that competitive advantage is going to come for new startups.
That's great. I think that's a common theme that we're seeing across the board, which does then really nicely roll into my next question. So thank you for giving me that nice segue. Micah, you've been working on this since you were a Cornell student. So looks like 6 or 7 years now, if I'm not mistaken there. I'd love to hear a little bit about the trends you've seen, if you've had to pivot to match up with some of these trends, and how you've kind of adjusted over the years to some of these up and coming ideas.
For sure. Yeah, no, and things have evolved a lot, even in 7 years. Doesn't sound like too long, but both on the hardware and software front. So I think when it comes to the hardware side, when we're looking at like the bill of materials and the components we use, things have shifted a lot. So we have a sensor that originally cost thousands and thousands of dollars. That's now hundreds of dollars. Right. And now it enables us to build a unit that can provide that ROI while still having that, the core data that we need to function the navigation stack. So that's like one example. And there's a bunch of other components like that that become either more commoditized or maybe there's more options out there. So that pricing has come down, which means the capabilities have gone up too. On the compute side as well, the power of the compute that we use is so much stronger than where we started, call it, that 6-7 years ago. So that enables us to be able to do more. We can use, we have more computational power. So then in terms of the actual navigation, now using machine learning, I don't think we would have been able to do that door detection, right, back in the day. Yet that's so important in terms of the use case. So these are enablers, right, on these component side. And also from a cost standpoint, it's been awesome. At the same time, with the supply chain challenges, I will say it hasn't been linear. We had a chip that cost $3 that now costs $30. Intel, actually has a camera that we use that cost $80. They decided they were going to announce that they were going to shut down that division. Everyone had, freaked out about the RealSense, said we need it. So then now they charge about $300. So it's been a roller coaster in many different ways on the hardware side. And then again, those enable software. So we've been able to do more. There's been more out in the robotics world that we can leverage too, different libraries. even ROS, which is called the Robot Operating System, which is used by a lot of different robotics companies today. They released ROS 2.0. Which helps with, how much of the compute is needed. So it's much more efficient, and the capabilities we can do through that as well. So those have been just, a few different examples that we've seen and how things have changed. And then even before this call, on the manufacturing front too, COVID has had a huge impact on supply chain, which I think most people probably read and know, and with that, we actually were producing out in China. And there are huge issues with even just getting parts shipped in time and dealing with delays at, the ports and things like that. So we actually ended up shifting to North America now, where we're producing units, which has been a lot more smooth, at least for us, for our use case and on all the different components we have. So it's really changed how we think about product development, the capabilities, even use cases, and even the manufacturing that we're doing.
Great, thank you. That some of those sourcing numbers really cut deep there, but glad to hear that you're finding solutions. Ryan, again, you guys are doing the work for me of segueing for me. So Ryan, I'd love to hear a little bit about some of the challenges that you've come across, especially when we're talking about supply chain and sourcing. What advice you would have for someone who's really eager to get into the hardware entrepreneurship space, and how you've kind of overcome the challenges that you're dealing with?
Yeah, I'll start with answering the latter part of just going into the hardware space. I've learned a lot at the Rev Startup Accelerator this past summer, and primarily one of the biggest things is you got to build the right thing before you figure out to build the thing right. So making sure that your use case, right, the value creation is right for your customer. That's number one, and then you think about how you engineer it to be the correct performance, to be the correct reliability, to be the correct solution. For that, job to be done. So that's really step number one. And then obviously in terms of hardware, Deanna, you've seen our struggles too. Came up with a PCB layout, and then realized, last minute, some of these components becoming obsolete, some of these components becoming short, they're gone. And sometimes the vendor's website isn't updated. So you think you had some, and then next thing you know is like, no, actually we don't have that. So this causes a lot of iteration, a lot of cycling through designs. It's a lot of pain. So there's actually, unfortunately, not a good way to overcome that. What we're starting to learn is to be a little bit early and work with a reputable and good manufacturing partner. And this starts to become very important in our trajectory right now as we deal with a very large supplier in Taiwan. We presented them our board, our PCB, design, and they're like, hey, only 20% of your bill of material is what we typically use. And this company builds pretty much all your iPhones and, telecommunication equipment, laptops and whatnot. And their first recommendation is, if you can improve your bill of material and use 80% of our inventory or components in our inventory, we can actually lower your cost down because you have a lot of large players ordering the same thing. And there's a lot of access. We can just take those access that they've ordered and use it on yours. Right. So finding a good manufacturing partner, and then that best approximates what you're trying to build, and then trying to piggyback on other people all building or using the same component can really help you smooth out a little bit of that shortage and the cost in your bill of material. And so we're actually in that space right now. But of course, as a very small startup, we got to first make sure our base design works. And then you got to figure out the optimization opportunities. So my recommendation is start, with prototyping, making sure it works, then figuring out the right partner to do it with, then selecting components to optimize your bill of material. It'll go down over time.
I'm glad that you found a good partner to work with. I remember many a night over the summer where I think you guys were there all night sourcing components, just trying to get everything onto the board so you could put that order in. So I'm glad that you found someone to work with that's giving you some of that more reliable help.
Yeah.
So I want to take a little bit of a transition here, and then I see we have some questions from the audience that we can get to. But Anna, from an educational standpoint, is the hardware landscape, the current transitions and trends changing what upcoming engineers need to know? How is hardware engineering, like education, whether it's mechanical or electrical, how is that changing to adapt to all of the new needs of the hardware landscape?
I mean, this is a conversation that we are having today, actually, I'm going to be having one next week, among our various different partner companies. So at Epic, which is our manufacturing center at BU, we have a number of large companies that are our partner companies. And we're constantly having these conversations with them about what do we need to be training our students in so that they can become effective people downstream when they get hired by these companies. And a lot of it has to do with how do you work in an interdisciplinary space while maintaining a depth of expertise. So we're trying to figure out how do we teach our students to be domain experts, because and if you sort of think about the T structure, how do you give them enough depth? Because you can't just teach everybody everything. Because then you're not really able to do anything interesting because you can't begin to tweak those ideas or come up with new and novel things. So we need to teach them that depth of expertise, but we also need to teach them how to have conversations, or at least a language to have a conversation with other functional groups. So as Ryan was talking about going and talking with his contract manufacturer, if he didn't have that knowledge of, okay, I need to have a supply chain. Supply chains have delays. There are shortages out there. The more I can buy out of a single shopping box as opposed to going to 40 different vendors. Without understanding those fundamental principles, it's not really possible to have an effective conversation with your contract manufacturer. So what I find is the students come out of it either feeling like they have to know everything at an incredible depth of knowledge, or I'll just hire somebody to do that. I will just hire a contract manufacturer and they'll build my product for me. I will just outsource my app. I will just outsource my supply chain management or my 3PL. And the answer, I think, is somewhere in between. And I think teaching students how to very quickly get the lay of the land, understand what's happening in a space, and have that technical knowledge so that they can have those conversations, but with the understanding that they're not going to know everything coming out, and they're going to have that conversation with somebody at some point in the future. And I think I struggle with this with my juniors. I teach a junior level manufacturing process class, which is the reason why I wanted to be able to brainwash every single one of the undergrads that came out of mechanical engineering. So I wouldn't let them add any faculty to it because I wanted to teach every student the way I wanted to teach them. And it's been really interesting. It makes my students' head explode because the problem sets are open-ended, and I have data that's not relevant and data that's missing, and they have to go out and do research, and there's no clear answer. By the end of the semester, they begin to figure it out. But at the beginning, they're so focused on what is the answer to the problem set. And so as we have these conversations with our industry partners and with academics, I think it's really that ability to train engineers who can think flexibly, who can be curious, but still have that technical depth so that they can solve real problems. It's it's a conversation we are having a lot of, and there is no easy answer.
Yeah, I think the starting point of the answer is not always X equals 8 is great to hear that's getting into the education that students are learning to handle it. So we have a couple questions from the audience. I have one that's specifically addressed to Micah. It's a little bit about how you handle the trade-offs between power consumption and then adding more features, because predictions put more stress on the hardware, and adding more features in obviously is both a good thing, but comes at a cost. And so as you're looking to advanced Rosie, how do you kind of handle that trade-off?
Yeah, for sure. It's a really good question. So in terms of the power consumption, that's actually been something we've talked about and thought about for a while. We're leveraging the same batteries as a Tesla right now, but it's kind of limited in terms of our robots use 15 cells. A Tesla uses 4,000. So you can think of it as a mini Tesla. But in terms of the advances in power and in batteries as a whole, there haven't been a whole bunch, honestly, over the past 6-7 years, at least that have, I'm sure there have been a decent amount behind the scenes, but in terms of, really getting commercialized and something that we could use and shift to. So actually going back to the conversation around the computer that we're using, it's much more efficient And then ROS 2.0, for example, the software stack that we're leveraging is much more efficient, that uses a lot less of the computer itself and power draw that's necessary for that. So I think there's kind of been this evolution on the electrical side and electronics and the software that we can then leverage through that and build into that. That help kind of keep us from overusage of power, overusage of the computer itself, and that to me has been how we've been solving it now. And then of course we're excited for the day when batteries are more efficient, can hold more, and then we'll definitely kind of shift down that path.
Yeah. Ryan, I'd love to address a similar question to you, maybe from a slightly less technical standpoint, thinking specifically about AI and power consumption. But I know you've been dealing with evolving your business model, thinking about new features and going through your customer discovery. What did that look like for hardware? Can you talk a little bit about the challenges that you had to walk through in terms of choosing features and talking to customers and making sure you were building the right thing, which you alluded to a little bit earlier?
Yeah. So, as you know, our version 1 of our prototype actually rotates like a Rubik's Cube. It's pretty fanciful. And, is it really necessary? Right? Those are the questions that we need to ask ourselves, because once we know it's necessary, then, it's really lock it in the design and do our first build and then give it out to people for future iterations. And so for us, right, our strategy was always been, let's just, double check, measure twice and cut once, that type of view. And so, as you know, over summer, we printed all kinds of cubes, solid ones, modular ones, no rotation, full rotation, and present it to people and ask them, hey, what would you choose? Where would you put it? What would you plug in? How would you use it? And there's some really surprising conversations that can come out of this interaction with people. And pretty much really, it doesn't take that many people to kind of ascertain your features. Things starts to repeat after themselves after maybe 30 or 40 users. And you start to get a good view of, hey, what's necessary? What's going to be costly, what's going to influence your number of parts that you need to do injection molding on. And then, is this feature a V2 of your product, right? It doesn't mean, even if you don't select it for V1, doesn't mean it's not a necessary feature that you can't develop in the future, down the road. And so that is what kind of drives our decision. Now, of course, as a business, we've been executing on the line of smart software, small hardware, just to start off with. Because hardware is capital intensive, and so to the extent that we can minimize a lot of the features in the beginning in the hardware and really create the value on the software side, or double down on the value on the software side, it helps out a little bit to get us started. And so those are sort of how we've navigated our journey.
So what I'm hearing there is that when we have better batteries, Mica's V2, V3, V4 can build in all these extra features that they've put off when we've got the battery capacity for it. So thank you, Ryan. We have a general question here that I can put out to all of you, and it ties back to one of our earlier questions around AI and infrastructure almost. But do you know of, or have you heard of any companies that are using AI for quality control? I know we might have touched on that earlier. I'm not sure if you have any specific instances. Anybody has thoughts on that?
So I don't necessarily know companies that have done that, but there is a trend, for example, especially in customer complaint analysis. So you'll find even for small companies, you get a lot of returns and you get a lot of open-ended text data. It may be coming from multiple points of view. It might be coming from an Amazon. It might be coming from an online. It might be coming through a call. It might be coming through the web. It might be coming through the device itself. And so there's been quite a bit in trying to identify emerging trends in that warranty or customer complaint data so that you can get ahead of it. Because by the time you begin to notice it in the data, oftentimes it's not solvable, and you also have got a ton of product in the pipeline. So identifying and finding those really early life failures, or those failures when they're still in the small numbers, gives you a much longer runway to catch them. So I'm not familiar necessarily with the companies that are doing that, but I do know that I have seen some work in that field. The other one is around in optical inspection. Being able to look at products, and there's been a ton of work in that space as well. But in terms of just quality control, looking at data, figuring out what to measure, et cetera, a lot of that is just, as both Mike and Ryan are alluded to, a lot of that is just understanding the product, understanding the control points, understanding how the customer is using that, and then using that ongoing quality data to educate what you need to be changing in your product.
I think she nailed it. And we use a couple of tools that help a lot with that. So in terms of, I want to emphasize kind of the customer facing challenges, things we see in the field. So we use one, which is more kind of from a just asset management perspective. I don't know if it is considered as AI tool, but Upkeep is one group that we use. And that helps us track data on the robots and where they are. What issues there we can actually track. We can have like a checklist in terms of quality control before we send units out to customers. And then on the back end of it, of tracking the assets, what issues have come up, and being able to see trends around that. So that's been an awesome tool for our team, especially our technicians, to be able to track different information. Another tool that's more from the customer success standpoint that we use is called Churn Zero. And I think they do actually implement AI in there. Churn Zero actually looks at different data around usage, around failures in the field, a bunch of different data points that we kind of feed into it. And what helps is it actually tells us what % likelihood a customer is to churn based on those data points using AI. So that's been awesome. So we can kind of get ahead of that and be more proactive of, hey, we're seeing these sort of patterns with this client or this account and others. So those are two that we use now that we're more established and have hundreds of units out there that I'd highly recommend you check out.
That's great. So getting towards the end here, I'd like to just take a second, have everybody go around some big takeaway thoughts. Hardware, AI, machine learning. What are your takeaways? What do you feel optimistic about, perhaps? What would be your message to send out at the end of this session? I'm not sure, Anna, if we can start with you, maybe?
Sure. I think, and Ryan and Micah both touched on this point, is make sure whatever you're building is relevant. Building things is expensive. It's time consuming. It absorbs a ton of energy. And a lot of times I see people prototyping or building products, and they do one of two things. Either they prototype what they know as opposed to what they don't know. And I would say that's probably one of the number one big mistakes. Because if you already know something and you know how to build it, it's not very interesting and you're not doing any risk reduction around it. So you really want to be building what you don't know how to build and what you have questions about. And then the other one is the bright, shiny object problem. We're all entrepreneurs. We all love new technology. We all love to play. We all love our new ideas. And there was a time to be playing, and then there's a time to be getting a product out the door. And sort of making that transition from the sandbox to the assembly line requires you to stop playing and focus. And oftentimes we're our own worst enemies. And it's I would just sort of caution against those last minute, this is cool, our customer said this, and we want to go build this feature in, because most likely that additional feature is going to break it. So prototype what you don't know. Focus on the risks of what you don't know and how you're going to answer those questions, and try not to add things at the last minute, because you're going to have enough problems at the last minute between supply chains and softwares that don't work, or a license that all of a sudden you can't get, or a shipping failure, or a sudden interaction of, the door problem or whatever it is. There's enough unknowns out there as you're doing this process. Try not to add any that you have control over.
Great advice. Thanks so much. Ryan, do you have any thoughts along the similar vein?
Well, first off, read Anna's book, Product Realization. I was given that book when I started the TechStars program. And so very, very helpful. Just, drawing from, folks who've done this and documented this, and helps explain a lot of, what you're going through. The good thing is people have built hardware before, so there's a lot of references that you can draw on and find the right mentors to help you get through different stages. My personal experience going through this journey is really make sure that what you're building works first. Don't worry about the optimization of it. Don't worry about building the perfect thing. Building the thing that works and bring it to your customer as soon as you can, and let your customer tell you what that experience is. And then once you realize that this is the thing that your customer wants, this is something that they're willing to pay for it, that's when you start to think about, okay, how do I optimize this? How do I bring this to scale? It's actually to your advantage that in the beginning, you don't have that many users. It's really hard to make a lot of hardware for a lot of people in the beginning. So it gives you some room, right, to be more focused one-on-one with the user and really get some insights and feedback and to iterate on your product. So that's just my advice here, is just making sure first it works, and then you figure out the optimization aspect of it later.
Great. All right, Micah, any last thoughts, advice for up and coming hardware entrepreneurs or people interested in hardware?
Yeah, so I think just to echo a couple of those points, I look at innovation, there's kind of three categories. There's vitamins, which give a little boost. You could probably live without. You have aspirin, which solves a pain point. You have a bad headache, solves it, makes a noticeable difference. And then there's oxygen, which you just can't live without oxygen. That's how we've been thinking about, in terms of the product market fit, the need, like really having, in terms of what we're building, focusing on the oxygen, because ultimately that helps sells itself in a way. So I think that's core. I think what Anna mentioned earlier around simplify, focus on what those true features are. I think you both mentioned, really strip down the cool functionality to what's needed. And then it's so hard. So like simplify it as much as you can, because regardless, it is a brutal roller coaster. At the same time, I think it's so exciting. I think technology has stagnated like crazy in the physical world. You see all these apps, you see our the software tools coming out and things getting updated. When you look at the physical world, it actually looks pretty similar if you're driving down the street or going into buildings or whatever it might be. So I think there's this huge opportunity. I think it's going to be a revolution where we start seeing our physical world completely transforming. And I think there's communities built around that too. Like for us, the reason we've gotten to where we are is Cornell. It's these advisors that I've been able to work with. It's experts that have gone through it before. And I think Cornell is an amazing resource as well. And Rev, in particular for us, was huge. And I assume for Ryan, helped kind of get them to this next stage too. So asking for help is awesome. And a lot of people want to. So let's do it and let's change how the world works together.
Great advice from across the board here. I think you've all made the point that hardware is not easy. It's called hardware for a reason, but it's a lot of fun. So thank you all for your time. Really appreciate all of your insights. I'm going to take a few minutes just to wrap up here and mention that our prototyping hardware accelerator at Rev that both Ryan and Micah went through in the process of building their products, applications for next summer do open today. So we're super excited to have this launched a little bit early for you so that there's a chance that you can get in sooner. So those are open. The QR code is up on the screen. That'll take you to more information about the program and to the application link. So if you're interested, we invite you to apply. You can always reach out and contact us as well. We're happy to give you more information. And we also have info sessions coming up in the next couple of weeks as well, where we'll go into a little bit more detail about it. But thank you, Anna, Micah, Ryan, for all of your input today. It was a great discussion. I love learning a little bit about what the up and coming is in hardware, and especially with all the advances in software and AI today. This was really insightful. So thank you all, and we'll wrap up there.